Section 7.5 is titled Complex Rational Expressions, but relax, don't scream, don't holler, it's okay. Even though they are complex, there is nothing new in today's lesson. It's combining, the reason it's called complex is because it's combining a lot of things that you already know. So there's complexity, but it's not difficulty. All right, you can do this. Here we go. The first thing you need to know when you're dealing with complex rational expressions is that a fraction bar means divide. So anytime you see a fraction bar, you can know, oh, I can just divide this. And you've done this already. If you had 1/2 to change it into a decimal, you took the 1 divided by 2 and you got 0.5. So that fraction bar means divide. So that's going to help us today. Our steps for simplifying complex fractions are this. Step number 1 is just simplify the numerator and denominator. So get the numerator and the denominator as simple as you can. Work those down as far as you can, and then after you've got simplified numerator and denominator, then just write it as a division problem and solve it. All right? It really is as easy as it sounds. Here we go. So a complex fraction, or a complex rational expression, is the same as a complex fraction. This is a fraction over a fraction. That's what a complex fraction is, all right? It's two fractions put together. It's easy sneezy. This just means 2 over x divided by x over 3, all right? And you know how to divide fractions. In this case, 2 over x and y over 3 are simplified as far as they can go. So we're simply going to say, well, this means 2 over x divided by y over 3. And remember, when we divide fractions, we flip the divisor. So 2 over x, flip the second number and multiply, so 3 over y, and then just multiply straight across. 2 times 3 is 6. Oh, see if anything will cancel, and in this case it won't. All right, so 2 times 3 is 6 over x, y, and you're done. Easy, easy, easy. All right, so simplify the top, simplify the bottom, and then combine them. All right, now that one was easy because they were simplified already. So let's look at something like this. You've got a mess going on. Oh my word. Remember what I said. It's all stuff you know how to do. It's stuff you've done before. We're just going to do it all together in one problem. All right, we're going to put all of your knowledge together in one. So you're going to look to see. First, ignore the denominator and just look at the numerator. This is just 1/4 plus 2/3. So what you need is a common denominator. And if you look, 4 is 2 times 2 and 3 is just 3. So you're going to have to multiply the 4 times 3 to get 12. So 3 over 12. And you're going to have to multiply the 3 times 4 to get 12. So 2 times 4 is 8. So you've got 3/12 and 8/12. 8, 9, 10, 11. So in your numerator, you have 11/12. All right, so all I did was add these fractions. I had to get like denominators and then add their numerators, and 11/12 is what 1/4 plus 2/3 equals. All right, so if you're struggling with that, then go back and look at finding like denominators. Okay, so now this is all over 3/8 minus 1/6, and 8 is 2 times 2 times 2, and 6 is 2 times 3. So my least common denominator is 2 times 2 times 2 times 3, which is 8 times 3, 24. That's your LCD. So 24 is your denominator. And 8 times 3 is 24, so you got to take the 3 times 3 is 9. And 6 times 4 is 24, so 1 times 4 is 4. So now you have 9, oh look, I used my subtraction sign as a division bar. So you have 9/24 minus 4/24. So 9 minus 4 is 5/24. If you need to write that step out, please feel free to do so. 9/24 minus 4/24 equals 5/24. Now we've got a division problem. So what we're going to do is 11/12 divided by 5/24. So now make it into a multiplication problem. 11/12 times 24 over 5. Oh, and you can look and see 24 is the same as 2 times 12. So my 12s will cancel. And then multiply straight across. 11 times 2 is 22. And 5 times 1 is 5. 22 over 5. And you can leave those improper fractions. All right? So all you're going to do is simplify. Just look at one part at a time. They're all simple little problems, but it's all together in one. So don't let it overwhelm you. Look for the little piece. Look for the little piece that you know how to do and do that little piece, and then you'll whittle it down until it's just an easy problem. All right, let's do the next one. This one's a little bit trickier because your 5 doesn't have a denominator. 5 plus x over 3, well, that's actually even easier, because if there's not a denominator here, that's the same as 1. And so we can just borrow this denominator, right? If we just make this denominator 3, all right, we make this denominator 3, then it matches. Now remember, whatever I do to the bottom, I have to do the top. So 5 times 3 is 15. So 15 thirds. So now I have 15 thirds plus x over 3 in my numerator. So that's the same as just 15 plus x over 3. And in your denominator, this is 2x and this is x. Oh, well, I just have 2 times x. I already have x. I need a 2x. So I need to take this times 2, which is just 8. So 8 over 2x. So this is 8 over 2x minus 1 over 2x. 8 minus 1 is 7 over 2x. So now we've got this fraction over this fraction, right? That was just easy. Oh yeah, I forgot. It's 2 problems. It's okay. It's 2 problems that you do kind of at the same time. So now it's this divided by this. So 15 plus x over 3 divided by 7 over 2x. So now we're going to flip and multiply. So 15 plus x over 3 times, flip it, 2x over 7. So now remember, we're multiplying, so you got to multiply all the way through, okay? So 2x times 15, 2 times 15 is 30x plus 2x squared, all over 3 times 7 is 21. And you're done. Easy sneezy, right? Oh yeah, you can do this. Here we go. Last one. Now, in this case, these are really simplified already. It's not two fractions, so they're simplified. So this one, we're just going to make it into a division problem. So it's this divided by this, right? This says this divided by this. So a over a squared minus b squared divided by b over a plus b. So change it to a multiplication problem. A over a squared minus b squared times, and now flip them, a plus b over b. Now when you multiply, remember that you can factor this and see if there's something that you can cancel out. So remember a squared minus b squared, do you recognize it yet? That's a perfect square minus a perfect square, so it's just going to be a plus b, a minus b. If you don't see it, that's okay. Keep going. A times a is a squared, b times b is b squared. Negative means different signs, and the middle drops out. Okay? Now we can see, oh, looky there, the a plus b cancels out. So now on top, all we have left is a. And on bottom, all we have left is the b times the a minus b. So we can just leave it b times a minus b, like this. And you can leave it factored. Easy, easy, easy. So really and truly, complex fractions are kind of a misnomer. They're not complex. Well, they're complex. They're not difficult. Remember, the complexity simply comes from you're going to do a lot of different things that you already know in the same problem. So don't let it freak you out. Look at your numerator alone and simplify that as far as you can. Then look at your denominator alone and simplify that as far as you can. Then it's just the numerator divided by the denominator. So you flip and multiply. Don't forget to flip the second number, the second fraction, and multiply straight across. You can cancel what you can cancel and make it even easier, and then you're done. All right? I will see you next time. That was an easy one.